Okay. Okay, right. Wow, my internet... It seems like my internet has died. Well, it died and then it started running again. That was great. I'm not sure whether you got the... I said about the fact that my internet is occasionally temperamental. And that would be very, very ironic if that was the last thing you guys heard before stream stopped. Okay. So, what was I doing before you guys got to me? So, it was writing. Oops. It was writing this comment, right? It was about that, I reckon. Can I get this window to cooperate? My all of the windows on my screen disappeared when the internet died. So what I was doing was I was thinking for the rest of the stream. Oh wow! Okay, so there's a lot of stuff has changed since then. Okay, wow. So much talking that I did. Okay, so basically it was that the only real thing that's happened is that I've made a thing to fix. Before we had a, if we take this code out, there was we had a bug with the undo system, which pretty much you could write some stuff. So we could say like replace true and then replace false. And then if we undid twice and then now we're back through the undo thing and now I don't know, we replaced it with an object. And then we undid, it would take us to false because it started off, like it's just added to the end of our history, even though we have kind of the startup line that's here, and then we replaced it with true and replaced it with false, and then we undid back, so we're back at the whatever it had to start, and then we replaced it with an object. What we'd expect to happen is that the object just replaces, it kills all of this, all of the future history that we've just removed, and then it replaces, adds an object. But that's not what it's done. It's added the object to the end, so we can go undoing from the object. We get the object, then we get false, then we get true, and then we get the startup, which is as far as we can go. Which was not very ideal. So what we really wanted to do is to delete these two lines of the history, and so that it's just the startup code, and then replace with an object. There we go. So that's what this code was doing. Now it should work as expected, that we replace with true, replace then with false. Now we undo twice and then replace with an object. And then now the only thing we have is that and the empty object, which is now what we're doing. And I committed that change as well to the branch, which, if we go to the GitHub thing, okay, that was what changed in the latest commit, was just that I replace cursor with the new code, and that I do intend to rebase that into this commit at some point. So this commit will just disappear by the time it gets to master. So what I was also talking about was how to potentially implement the cursor, because what I was saying about the ways I had intended syntax trees to be stored makes a lot of sense for compilers, which is where I got it from. But from the point of view of a text editor, it doesn't really make sense. And the thing that doesn't really make sense is the the deduplication. So if I were to have 1 plus 1 as a simple example, or maybe 1 plus 1 times 1, then there are, just like reading off the syntax tree, there's one node, we'll call it number 1, and that's just 1. And then we have number 2, which is another one. That's this section, this one, and then we have this one, and then we have this one, and they're all the leaf nodes. So there's that leaf node, and then there's another leaf node. And these would all have different positions in the text, so they could all be treated as different. And then the plus is going to be number 4, and we'll just call that number 1 plus number 2, which would just be the whole of this bracket. And it's clear from how, so we could have number 5, which is, why, classic, okay. Okay, let's just do all this again. I will one day figure out how to be. Yes, ideally, ideally I'd have another monitor. I'm currently just using my laptop, which is fine. It's reasonably fast, and it has a webcam, which is good. Oh, and you can't see the top of my head. Okay, there we go. That's better. But it means that I can't have OBS open at the same time as doing code. So I can't see what you're seeing. It is the basic issue that we're getting. So let's say we opened some text like this in Sapling, and that it's just some language that it is expressions as maths works. What we could do is we could say, we could figure out how this is going to be turned into nodes, which is that there's one node, which is the first one. So we call it 1, or like 1. Yeah, let's just call it 1. Then we have number 2, which is also a 1, because we're going through all of the leaf nodes. We have 1 here, and then we have 1 here. And we need those 2 before we can make 1 plus 1. Because the plus needs the 2 ones as children. So we could have number 3 is something that takes the form of 1 plus number 2. Because these 2 ones are in different locations. So one way of thinking about this is that they should be different. And then we could say number 4 is just number 3 but with brackets. So brackets, number 3, bracket. And then number 5, we've got this bit read out so far. And then in order to do the times, we need the right-hand one. So we need number 5, 1, which is the last one here. And then the whole expression, number 6, which is the root, is going to be number 4, which is the brackets, times number 5. And this is how you would represent the tree. But what the Rust compiler does, and what a lot of other compilers do, is to observe that these ones are, in fact, the same. That there's nothing different about them because they're in different locations. They all mean 1. So we may as well remove them. So we could just remove this, and now number 3, I won't update the indexing because this is easier. This is, in fact, number 1 plus number 1. And then number 4 is number 3. There's no other way of, we haven't got 1 plus 1 yet. And number 5 is just another 1. That's the same as number 1, as the first node. So we just take that out. And then this becomes number 4, node 4 plus node 1. And this is what I envisaged Sapling could do. Because this is really nice and memory efficient. And the reason why compilers do it is that, first of all, this is memory efficient because you're not duplicating anything. And it's really easy to see if 2 nodes are equal. Because if you do this, let's say I added another number 7. And this was also the expression 1 plus 1, which turns into the first node plus the first node again. The thing is about this that we can immediately see that this is the same as 3, because at the top level it's just number 1 plus number 1. So we could just remove this and say 7 is the same as 3. And now to compare syntax trees, all you've got to do is just compare what are their numbers. Because the only way two things can be the same is if they have the same number. And that's why compilers do it. But the thing is, if you're passing around cursors, if you're trying to edit a syntax tree, then this is kind of crippling to have to do this. Because now a cursor, you can't say, oh, this node, like, I don't know, say, as it was before, if we undo a whole load of changes, then we could just say, suppose I'm editing, I have this one selected. Or let's say I've got this one for the sake of argument. Then we just say cursor is some kind of pointer to number 3 or address number 3. And then that would be fine. And then if we wanted to, when we were printing this, the way Sapling figures out which bit of the text belongs to which node is that it says, okay, along with each block of text in the input, it says, instead of just returning, I don't know, a bracket, then the character 1, it returns along with it a reference to the node that owns that symbol. So it would end up with something along the lines of 4 owns the bracket because the bracket is here, and this is owned by node number 4. The 1 is owned by 1. And then the plus, the white space is not owned by anyone because we don't really want to highlight it. The plus is owned by 3, then this is 2, then the next bracket is owned by 4 again, and then the star is owned by 6, and then this is 5. And we could do it with the deduplication, so these would be the same node. But now, when we come to selecting it, we can't just say, oh, the cursor is at number, whatever, say number 2, because now all of these 3, all of the ones look like they're the same. And so that just becomes a whole lot of tedium to have to do that. So I figured it would just be easier if Sapling just simply stored all of the nodes multiple times. You can, of course, if I were to say add another times on the end, then this doesn't change. That doesn't change this whole section of the tree. So we could just leave it, and then in the next version of the tree, in the next history, we need to store this in case we undo to it. But the new tree could just be say, oh, it's old tree. There's a pointer to the old tree times 1. And that's okay because, and this would be a new one, so we'd end up with nodes 8 and 7 in the order they would be added. And that's okay because everything that we could possibly want to select is still its own node, and that's okay. Even though this whole section appears now in 2 different trees, and it's kind like you could kind of say that that's duplicated, but it's kind of not. So I need another drink. So I reckon this is a fairly good strategy. If Sapling does end up using loads of memory, we could probably figure out a way around it. But because like nodes in a syntax tree are probably not going to be very big, I figured that we probably won't have a use. We won't have to store loads and loads of them. So this strategy should probably be sufficient. It also has the nice side effect that it makes cursor movement. I think it will make moving the cursor a bit easier. So what I think we should do to represent the cursor, I'm not sure how undoing through the cursor, like what undoing should do to the cursor. I don't know what normal text editors do. We could look it up. So let's just open the main file in Rust. And then if we move the cursor and write some stuff, and then undo that, okay, then it moves the cursor. But what happens if we redo that, do it again, and then move the cursor back and then undo? Okay, so Vim seems to save the state. It saves the state of the cursor in the history. So however we store a cursor, we could just create a new type here and call it cursor. And for the time being, I think this is just going to be a vector of U sizes, which is the child numbers. And then we have our history is a vector of not just what the root is, also what the cursor is, which will cause a whole load of issues. At this point, in order to refer to the root, we want to... The root is kind of the empty vector, because what we're essentially storing here is we're storing a vector of which children we have. So if we run this, in fact this won't run. Whoops. Yes, okay. We want to, we want to just take the first index out of that. Where is it again? New root, and then what do we want to put here? So where does the cursor want to go if we replace the cursor? Okay, so we're currently just the root again. So we want to just reset the cursor to being the root for the time being. Let's leave another to do. Once movement is fixed, we need to so this has a nice side effect that we don't have to move the cursor if we're replacing anything, because it will turn into it will point to a different node, but the path that we need to get there will be the same. So we need to somehow preserve the cursor location. Okay, that will just remind me to fix things. This should compile, I think. So what we've kind of got is that the root node that we've got selected right now is just like, it has no path. It's the empty, it's the root, right? It has no path to get to it. But if we were selecting true instead, that would be no path to get to the root, and then it's the first child, so it would be just the vector, the list of just one. This false would be just the list 2, and likewise for this object would be list just 3. And then the way this bit is structured is that the semicolon, so this kind of this pair is its own node in the syntax tree. So this would be nothing for the root, then it's the third child, and then it's the first child within that. So that would be, this semicolon is 3-1 in the cursor thing, and then say this true is 3-1 to get to that 1. So 3-1-2, because this is the first child of the colon and this is the second. And if we were to replace true with something else, it doesn't change the cursor's position. So now, in order to get the cursor, we're currently just returning the root all the time. And instead what we want to do, in fact, I reckon we should probably track the current cursor location. Whenever we do a snapshot, we want to store the cursor location. But I think for the time being, we should have current cursor. Maybe tersify these names at some point. Oh yeah, I want something. Let's just. We initialize to the root because the root of the syntax tree has to exist. So now, in order to get the cursor, we. Is there an elegant way to do this? I wonder. I don't think so. Let's just, for the time being, let's just do this. We essentially need to. We start at the root, so we need some mutable. We need to have some node, and that's root to start with. And then for every step in the current cursor. Ooh, I hear fireworks. It's bonfire night here. So technically on the 5th of November in England, everyone sets off fireworks as a thing. And this being the closest weekend to the 5th, a lot of people will be doing fireworks now, I reckon. So, where was I before I got distracted? Yeah, okay, so we're at some step in the path, and we know we need to go to child indexed child. So now node is now node.children. And then at this point we could just index and say just child index. But let's fix it. Oh, it's self.current cursor. Can we do this? Okay, we need to do this. Does that work? Okay. So I think just doing an index here is not great, because we could end up in a situation where the child index is invalid, so there aren't enough children. So for example, we go to the root and then we end up with just the array 4 somehow as our path, and that's root. Then we go down a level, 1, 2, 3. Oh wait, where's the 4th? So that's invalid, and the reason why it would be invalid is that this this index would fail. So I think we should replace with get, and now we have to match. So we'll just say if let some new node is this. So essentially we're checking, does this child actually exist? If it does exist, then node equals new node. So if it does exist, then we step down to it and keep going. Otherwise, we just return the node straight away, wherever we got to. And then perhaps we should log a warning. But the terminal is eating all of our printing output, so we can't do that right now. I need to fix that, because being able to debug print is basically essential. Print warning about how the fact Okay, so I think this should just work. It should compile at least. Okay, and now the root is the path, because we initialize our current cursor path to being just the empty list, which is the root. And now this should let us implement some of the cursor movement. Because currently moving the cursor even to something, oh, what were my key bindings? I can't remember. I think J and K were moving to children. Is it C? Yes, it must be C because it crashes. So what we need to do here is we need to, why does Vim do this? Match direction. Have we got direction in scope? Yeah, we have. Okay, so if we move down the tree, that's the easiest thing to do. Oh, yes, classic. Forgetting how the syntax works. So if that does work, then we should say, what is our current cursor? Let current cursor. Oh, current cursor. This should be called current cursor path, because it's not the pointer to the cursor. It's a path. And let's, for the time being, return let's just return an error message to say that we haven't implemented this. Direction not implemented yet, and then just pass direction in. I think that should be okay. Returning an option string, this is essentially this whole thing is pretty much just an error message if it's something. And if this returns nothing, then it assumes that the editor structure assumes that the movement was successful. So if we're moving down, then what we want to do is we want to add 0 to the current cursor path. So we would want to push 0. And then return none, because things were successful. But this might not work. This might, if there are no children, then this is invalid. And although it would do the right thing, this function would do it. It's kind of bad to like, you shouldn't invite undefined behavior, is what I was trying to say. So what we should do is, having got the node of the cursor, let's check, does the current cursor actually have any children? So if this children dot is empty, then return some string that says something like cannot move down the tree if the cursor has no children. And this needs to be a string, so to string. What? Oh, okay, yeah, and then if the current cursor does have children, then we return that. We add the 0 and return none because the move was successful. I think that should now allow us to go down the... So why has that? Because this is the behavior that I was saying Sapling shouldn't do, because that would mean that we've added. It would mean that both trues have the same address. Like these are exactly the same memory locations. What is this? Okay, I think I know, because we're using equals, not. Okay, I think I have the solution. Where is it? Where's the render tree? So somewhere in here. Yes, it's this that's causing the issues, I think, because what we're essentially saying is R is a reference to the node that this text belongs to. So this is the fancy stuff that gets the root of the tree, and then it says, okay, what pieces of text do I have to print in order to do it? And moreover, what it does is it returns not just the tokens, which is T here. We could probably rename that to TOC or token. It also returns a reference to what node it is. So this, let's call it node. And the real issue is that we're using equals, which is not comparing pointers. It's saying, are the two nodes equal? And of course, the cursor is technically pointing to this. So if the pointers are equal, then the data structures must also be equal. But this true is also equal to true. So we need to figure out, instead of doing this equals, we need to just straight up compare the pointers. So is there a way to do that? That's the thing. Let's just leave it as working. So I reckon if we, does this work? Haha, you can see Firefox and all of my tabs. So Rust compare two pointers. Oh no, references. Ooh, standard pointer equals. Oh, okay, I think this does what I want. So it's this standard pointer equal. Hopefully it's not unsafe to do this. Shouldn't be. Okay, that seems to work. I wonder if this does what we expect now. What was the keyboard? Yes, it does. That's so great. I was very confused when that happened. So now we should be able to try and go down a step. And it's not crashing, but it's not printing an error either. Where's this? Oh, that is very true. Hold on, did the browser... Oh, is this what happens when I lose focus of the browser? It just turns into a thing. Oh look, hopefully there isn't anything. Oh, we got inception happening. Is it long enough that we get a third one? Oh, we've got a third one. Do we have a third one? No. Okay. Anyway, enough of this. Let's switch to what you should have been saying. How much have you missed? I could really do with a second monitor. Perhaps that could be a Christmas present. I'm not sure whether my laptop could hack running a second monitor and streaming, though. That's the thing. So how much did you miss? Did you miss my... so it was only me writing the cursor, the pointer is equals. Where's that? I can just quickly check where the changes are. That was in editor, right? Line 27. Okay, so I replaced the equals. Before this said equals. It said this, and we were comparing, we were doing what I think is called structural equality, which is, are these two structures the same? Rather than saying, I don't care if they're the same, just are the pointers identical, which is what this does. And now we've got the behavior you can see on the left, which is that I can select one, I can go down a child and then I get to true. So I'm selecting one node but not the other, which is what we would expect. However, what's not happening is that we should get a debug print if we try and go below, like, so you can't see this, but I'm trying to move to the child of true, which is obviously that's doing nothing because there's no child to move to. But it should be printing, it should print whatever we returned. Move cursor. Okay, yeah, if some error message. I probably should have done this properly with error handling, but format on save. What? Yeah, it returns an option. Why is this? Oh, I forgot to say let. Okay. If let. So if we get some error message, then self.log.push, and then we want log level.warning. I think it's a tuple, right? So this, okay, log level string. We're pushing a tuple, log level warning, and error message. Does that compile? You guys can't see the editor. Okay, right. So now if we move there. Awesome, okay. And then direction up is not implemented, and neither is next and previous. I'm not sure what to call the directions, in fact, because and I'm not even sure what the keyboard shortcuts should be. Because the thing is that here, obviously, like up and down is kind of intuitive, because to go down from true, you ought to get to false. That seems kind of sensible. Hold on. Oh no, yeah, no, I don't know what I was expecting. But the thing is, for example, if the lists were just flat, which I can do with some hacks in my main function, which format? If we use a compact format, the idea is that because Sapling just stores syntax trees, it should now just work, and now we've got the compact thing, and we should go to the child and have true. And that should be okay. But the thing is, now true and false are not on top of each other. Like the directions have flipped. True and false used to be on top of each other. So whatever up and down keys you're used to, J and K are quite common in Linux programs for that, because they're closer, like they're easier to use than the arrow keys. But now they're left and right, and it kind of seems against Sapling's editing model that you should have to change. Like there should be just one keyboard shortcut to go to the next child and previous child, rather than having to worry about which direction they are. Because like if we overflow a line, for example, and then we have for you watching, we have true up here and then false over here. then what keyboard shortcut is that? I guess it's to the right, kind of, but that seems unintuitive. It would be much nicer just to have next and previous. So I want pretty view. So what are we doing? Okay, we're wanting to move more things around. So we can move down, but we can't move to different children. I'm not quite sure how to do this because we want, when we're setting this up, we need to know, in fact, let's just direction previous. What we're doing is we're going to have to figure out, so what we could just do, the naive way of doing this is to just say self.current cursor path dot last. Can we do that? Last mute. Haha, nice. Can do that. Oh, we should probably unwrap because I'm feeling cheaty. And then we need to say whatever the last one is, we add 1 to this. Does that work? Oh, we need to deref, I think. This should work. And then we return none because it was successful. Or we are just claiming it was successful. And this would kind of work. So this would, if the cursor path has length, then this would move us up. Oh, it's also should say minus there. My mistake. So this would work. And in this case, we can just simply check, are we going to go less than 0? If we can't go less than 0, then obviously, if we're going to go from index 0 to index -1, one, that will crash in Rust, that will panic in Rust because it's overflowing, because we're not allowing negative numbers as indices, and so 0 minus 1 just doesn't make any sense, and so the language would just panic, and Rust would remove the terminal, and the error message would get eaten because we're filling the screen. So what we could do, we need to check in either case, if we're moving up and down or to different children, we need to check if we're at the root. So if self.cursorPath is empty, if it is empty, then we return some cannot move to a child of the root. So this should, yeah, okay. Let's just appease the compiler for a second. Oh, and this is a string, so we need to say toString. Okay, so this will handle the case that the cursor path is empty. And in fact, we could do this differently. We could say if let some index is our current cursor path dot last mute. So this will say if there is a value, if the cursor path is empty, then last mute last mute will return it will return none. So we say else, and this is like our fail point. And then if the cursor path is empty, then it doesn't have a last value. So we return the thing saying can't move to the child of a root. And in here, now we know this is empty. Now we know it has a value. We can say if index is, if it's 0, then we can't move backwards because there isn't anything to move backwards to. So we need to say if this is 0, then we need to return some kind of error message. We can do that implicitly. Yeah, that's okay. Let's just do that because the compiler will stop ranting at us. If we are going to do this, then we can say cannot move something helpful, like cannot move before the first child of a node. And then if the index is bigger than 1, then we subtract 1 from it. And I think this should just be okay. We don't need to check. We just kind of assume that the cursor path is valid. And so this will just work. We don't have to check how many children the parent has, because if it has some number of children, and we're pointing at one of them, and we move backwards, then that's guaranteed to still be valid, unless we're moving past 0, which we've checked. So this should work. We can't. In fact, we can't move back up the tree. So let's just check that. Yeah. So if we try and move above the thing, we get the cannot move to a child with the root error. If we go down to the true, then it's a we cannot move before the first child of a node. And next is not implemented yet, because we need to think more carefully about that. Also, we could just implement parent now, which is like direction up, I've called it. I feel like these are not the best names, but they were. They do. They work. It's okay. So I think we could do. We could implement direction up, because this is just popping off the end of the list. If the cursor path is empty, then we want to return something like cannot move, or cannot move to the parent of the root to string. I reckon that should be enough. And then it's saying missing an elf clause. We need to none. And then otherwise we just pop the last value, because that has the effect of that just makes the number of steps down the tree we've taken 1 shorter, which is the same as moving up a step. We don't even have to check. Don't have to check that the parent is valid. We just say self.currentCursorPath.pop. This shouldn't panic because we've just checked that it's not empty. Does that work now? So we should be able to go down a child and then up. Haha, and then we can't move to the parent of the root, and we can't move down the tree. Okay, so now we just need to do, we need to implement moving down. And once we've done that, we can move the cursor anywhere in the tree. So I'm not 100% sure of the best way of doing this. Basically, the upshot is, if we did it unsafely, let's just say we did it the easiest option. We can remove that direction.down, or is it down? No, it's next. If I'm getting confused, then the names need to change. If I'm confused and I wrote this, how would anyone else do it? So what we could do is we could say, if the cursor path is empty, then we can't move. Where is the thing? Okay, let's just make previous and next to each other. If previous, hold on, this makes sibling. This should say sibling. Okay, and now that this makes sense, we should be able to do this. I'm missing an else clause, so let's just return none and pretend that everything was correct. So we can say if the cursor path is empty, then we just return an error message saying if the cursor path is empty, we must be at the root, and therefore we can't move it either way because the root is the root and can't have any siblings. And if it's not then we kind of want to mirror what we did here, and we can just say we just move. But because we can do this, we can say self.currentCursorPath dot last mute. We know this is guaranteed to be valid because we just checked whether the thing is empty. And once we unwrapped it, we need to dereference it to get the actual value, and then we add 1, which is essentially what we want to do. We want to move to the next child, which is incrementing the last value in the cursor path. So in fact, we can clean the code up a bit here, because we can tell if the list is empty by whether or not this is null. So we want to say if let some last index equals this, then do the successful thing, which is to move that index over by 1, otherwise return an error. Is that happy? Oh, we can't unwrap at this point, and we don't need to unwrap because that's okay. But the issue with this is all very well, and in most cases this would let us do it. This would work. We can move down to a child and then down and then back up, which is kind of feeling nice. We can also move. Oh, that's quite unintuitive. I think we might need different keyboard shortcuts for that. And then we can go up the tree again. Oh, should we make this a bit bigger? Because I know that we're quite a long way into stream before I did this, but anyway, this is probably easier to see. But the issue is, if we go down and then move off the end, then weirdness happens, because we are in fact off the end of that. But the way it works, we didn't panic if the cursor path ended up being invalid. We would have hit this line of code, which doesn't print a warning. If we just explicitly panicked here, then Sapling would crash when you do this. Child, then it would panic. Let's have a bit more text. Which is not ideal. We should ideally check that the parent of the cursor has enough children that we can in fact move. But having back pointers in our tree is not possible, because the same node, as I showed earlier, I'm not sure whether you could actually see it, but if you could see it, and as I explained earlier with the duplication, we could have the same node could be in multiple different trees. And in fact, it could. I don't see any reason why the same node couldn't have different parents inside the same tree. That seems like a perfectly reasonable thing to want to do. So we can't put parent references because there are multiple parents and we don't know which one to go to. But what we do know is that the last but one value of this value node, as we're stepping down the tree, which is what this loop is doing. This loop is using node to keep track of starting off at the root, going down to the right child, the correct child, until we reach the point that the cursor is pointing at. So once we return from that function, whatever value node had in the penultimate value of the loop, that is the parent of our child. And I'm not sure of a good way of doing that. We could potentially make another function called... So first of all, we could turn this into an iterator, but I don't really want to do that because that's a lot of complexity for not so much gain. And at the moment, I'm not worried about super optimizing Sapling because I just really want to find out whether a text editor like this is useful. If it's not useful, then there's no point having a fast but useless text editor. That can come later. So what I think I'll do is I'll just say make a function called cursor, too many functions, cursor and parent. And this will return a pointer to a node, which is our cursor. And along with it, it might return a parent. Because if, for example, we're pointing at the root has no parent. And so it just doesn't make any sense to have this. Okay, that's not a member of this. So we need to, we're currently inside and we're inside implementing a trait here. We're implementing what it is to be an editable tree. Because I envisaged that we might have other things that we want to test. So we need another impl dag. I'll fill those in once I've pasted this. We need to put this here. This is going to be arena, and then node is some syntax tree with the same lifetime, like that is stored in the arena, so it has the lifetime of the arena. For those who don't know what the arena is, or arrived after I explained that, essentially an arena is, let's finish that. If I open the main function to show what is happening, the very first thing the program does is creates an arena. And the arena is a place where you can allocate nodes. And it kind of does a similar job to the static lifetime, which is that the first thing that will happen is that the arena gets created. Then it gets initialized with a tree, which is what we've been seeing. And then the tree is created. So the editor is run. That's what these 3 lines do. And then at the end, we just implicitly drop everything. I believe Rust always drops things in the opposite order. So the very last thing to get dropped just before the program leaves is the arena. So the arena is just a way that we can have all these pointers, like we can have references, and that's okay, because we don't have to own the nodes, because all of the nodes are owned by the arena, but the arena outlives everything, so that's absolutely fine to do that. So that's why we have all these lifetimes. What's going on here? Oh, okay, this should be valid. Sort of. Okay. So we also, when we're moving down this loop, this code currently, all it does is produce the parent. So it produces the cursor, sorry. It will step down the tree, and at each step tracks one pointer and moves it down the tree. But what we really want to do is we need to track 2 pointers. We want parent. And this is going to start off being none. I'm going to just explicitly say that this is an option node. So this might be a node, because to start with, it points to nothing. There isn't a node that's a parent of the root. But every time before moving down, we need to say parent is some node. So we say whatever the node currently is, whatever node we're pointing at, we say that the parent is now that, and then we move down a step. So if we were to move down a step again, then we'd say move the parent to whatever the node is and then move. So that will be just stepping down. And if this never gets set, then it will just have the value none. So what we should be able to just do here is return node, which is our cursor, along with its parent. Just node parent. In fact, this is simpler. We could just break, and then the code does the same thing. And this function is never used, I think, is what the error is about. So what we could do now is cursor, instead of having this loop duplicated twice, it's not too much effort to track another pointer. What we could just say is if the cursor, to find the cursor, we find the parent first, and then so we say self dot cursor and parent dot 0. Let's just make a comment explaining that. To find the cursor first, find it and its parent, and then we just drop the reference to the parent. Ignore parent pointer. So we can do that, and now we don't really want to have to find the cursor, then figure out that we need its parent somewhere in here, and then run down the tree again. That's kind of a waste, particularly as in order to find the cursor, we found its parent, and then after finding its parent, we just forgot about the parent. We might as well find the cursor and its parent, and then just unpack the values. Cursor, can we say cursor parent? No. Cursor parent, there we go. And that value is never used. But down here we can say, in fact, yeah, so we can unwrap parent here. So what we really want to check is that the parent, here we're moving to the next node of the cursor, which is the child of the cursor's parent, if you like. And we've checked that the cursor is not the root here. Oh wait, you can't see my hands. Okay. So we've stepped all the way down the tree, we've got to the cursor, and we want to move it to the next parent of the next sibling. So we want to move one step down its siblings. And what we're checking now is that its parent, which we know is not the root, which we know exists, has enough children that we can in fact move a step down, and that's okay. And what we can do here is we can say cursor parent. We can unwrap. Let's just leave a message. We can unwrap here because the only way a node to not have a parent is if it's the root, and if it's the root, then the guard on the if statement then the if let would fail. So this code not run. Okay. Now if I come back to this, if anyone comes to this later, they'll know that this unwrap is safe. Or at least that we think it's safe for this reason. It might become unsafe later. So we've done this, and then we unwrap it to get the number of children. So we get this, and then this is a slice, so we can just say, how long is this? If the last index, if last index plus 1, can we do this without dereferencing? Maybe not. So if this is less than, then we should do it and return none. Oops. Because what we're saying is, this is the next value. Last index plus 1 is the next value, and we're saying, is it within the cursor? Is it within the parent's list of children? And if it's not, then we need to return some kind of error message. And we say, like, cannot move past the last sibling of a node. I think this should work. So, oops. Oh, we can't see all of our logs. Okay, let's make it smaller. So we can't move to the sibling of a root. If we move down, we can't move down the tree if the cursor has no children. That makes sense. We move down, cannot move past the last sibling. Okay, so now we can never have we can never have an invalid cursor at this point, I don't think. These key bindings don't feel very intuitive. Currently I've got J and K to move between children, which is up and down, or it's J is down, K is up in Vim, and that was just the key bindings I used. But that's really unintuitive for stuff like this, where the nodes are actually next to each other. I'm not sure what the best solution would be for that. And then C goes to the child, which I can't do, and then P goes to the parent. So, yeah, I think that's working, which is nice, because now, after my aggressive rewrite of everything, or practically everything in the code, we now have more functionality. And I'm pretty sure with the code as it was before, this functionality was basically impossible to do. Or not impossible, but it would have been a hell of a lot more difficult than this, which is quite straightforward code. It's not small exactly, but it's kind of logical. So I think I'm going to rebase. I'm going to add these changes to the branch, because we're working on a pull request right now. So I'm going to commit these changes and then do a bit of rebasing so that we don't have a load of fixes on the top. And then once I've done that, I'll merge the pull request, and then we can finish the stream, because I think that would be a nice way to round up. So let's do this. Can you see? Okay, you can see GitHub desktop. That's good. So these are the changes we made to the editor. We renamed some variables, which we should just consume that. That should just be part of the refactoring. And this change, which is actually a change, which is that now the log messages work. So I think let's just do the refactoring change first. So these lines rename some variables. This commit message will never be seen. Some variable names in editor. It's just so that I know where to put things. Also, just feel free to put questions in the chat if you have any. It might be a few seconds before I see them, but if I'm going too fast, or there's something that is like I haven't explained, then feel free to shout. So we'll commit these. This is now something separate, which is I suppose it's kind of part of the cursor movement changes that we've done here. How should we do that? Okay, let's just make it another commit. I think that's the easiest thing to do. Where add log messages editor. Wait, no, that's not very good. Make invalid cursor movements print warnings. I think that seems okay. It's a bit wordy, but anyone who actually wants to see what it does can just look at the code. What's all this then? This is the cursor movement. Oh, in fact, I've just had a thought, which, is it right? Yes, so I think the replace cursor still replaces the root. So if I go down a bit and then replace true, then it replaces the root, which is not ideal, but since the only thing we're doing is fixing up the cursor movement, I don't think that's a problem. Like, it needs to be fixed, but we already have more functionality than we did before. So all of this stuff is in fact just doing cursor movement, this entire file. Okay, this is a nice easy message: implement cursor movement. And let's just, for posterity, say something like, if the this doesn't change the fact replacing the cursor does in fact still replaces. Okay, and then we commit that. So if we look at the commit history, I think this is the last commit on the master branch. So everything above here, all of the stuff from here onwards, are new changes that are part of the pull request that I'm going to merge in a bit. But these top four are the stuff that we did on the stream. So replacing the cursor is part of the refactoring, because the functionality that we have here, which is replacing the root, was part of Sapling before. So that needs to just be part of, ideally, this would just be part of this commit. So we want to combine this one and this one together, which we'll do in a second. Replacing some variable names in the editor, that's part of refactoring the editor. So this commit and this commit should be combined. And then the invalid cursor is another change, which is not refactoring because it changes the outcome. And then implementing the cursor movement is another thing. So these two should stay, and these two should be combined. So I'll just hop onto, just switch back to terminals to do the rebase. Nope, wrong thing. I should probably not just randomly display my stream statistics. It can't be too bad though. Let's see, let's make this a bit bigger. Should have done that to start with. So what I'm going to do is I'm going to rebase. What's the commit name? I want to go back. I don't want to rebase stuff in master. So this one, it's, you can't see this, but I'm just copying a commit name. So I want to rebase everything above this certain commit in the history. And what rebasing is, for those who haven't seen it, it basically allows me to, allows anyone on their, once they've made a whole load of changes, you can go back and say, how do I want, I like my changes, so I like the overall effect, but if I made a load of mistakes and went back and fixed things, then I just want to remove that, because it doesn't, if that gets into the master branch, someone might want to know, what happened to the code over time, and they don't want to have to scroll through all of the changes. So what rebasing does is it allows you to update what steps you took to get to a result, which is just, I'm going through and cleaning so that once these changes get into the master branch, there's a nice clean history of, I rebased a module and then rebased the next module and then so on. So this is just a list of everything that happened. I added commands for the cursor movement, then the arena allocator, then removed the old node map code. These could possibly be the same commit, but I think it's okay to have them different. So what we really want is this commit, which is the refactoring editable tree. The code, what's this called? Element code to replace the cursor. That was the stuff that was to editable tree, right? Hold on, just let me check. because I don't want to miss rebase. Okay, yeah, because that was changing how the trees are stored in memory. That's not editor functionality. So I want to move that up to here. And this is a fix up onto the last one. So what the F says, F is the same as fix up, is saying to Git when it does, like when you change or when you update how this works, these two commits are just going to be the same. This one's going to get not destroyed, like it's not going to get removed, but its changes are going to become part of the one above. And then renaming some variable names is part of refactoring editor, so I'm going to do the same thing. This was the last thing I did before stream. Now we've got it should be working. I can see that Sapling is no, OBS is oh, okay. Sorry Marcus, that's like oh, okay. Right. What's happening? I wanted my I'm just moving some windows around. You probably can't see that. Oh no, you can't hear my dulcet tones. That's sad. Okay, so I'm going to leave these. These are two changes that are not part of the refactoring. They change how the code works. So that, and yeah, this is successfully rebased. And if we look at the history, oh good, you're back. We're just doing some rebasing, as you could probably see. So now we can see that in the history, we still have implement cursor movement. I'm not sure whether you can remember, but the commits that we had have disappeared. We now have, hold on, how's the best way of explaining this? Probably just to see that our changes have arrived. Where are the changes? Oh yeah, these are the changes. There's probably a bad way of explaining that the rebase just worked, and then we made our change history clearer. Don't know if that's a good explanation, but and in fact you couldn't see any of it. So okay, it worked is the main thing. And what I'm just going to do for the last thing is I'm going to push my changes to GitHub itself, because all of the changes we've done over the course of the stream are just they're all on my laptop, and I want them to be on the GitHub website as well. So I'm going to just git push origin, but I have changed some of the commits, and by default Git will only let you add new changes. It won't let you change stuff that's previously happened. And this is just like safety. You don't want to be able to completely rewrite everything. But what I'm saying, what I can tell Git is to say, I am right in changing history. It's okay. So I'm going to force, but specifically I'm going to force with lease. So I will only overwrite stuff that I have changed, is what it's saying. Which of course is in Sapling is everything so far, but in general I just like to be safe. It wants my username, and then that invalid username or password. Nice. What have I done wrong? Copy password. Oh, I'm just copying my password from off camera. That's my email address, by the way. That was right. I think I put my username as the password as well, and I think that's why it didn't happen. So now what we should have, okay, now you can see that. So now if I refresh this page, this is the page of the pull request. We can see that I did a force push and that our changes are now here. The invalid cursor movements, warnings, and the implement cursor movement are now valid. And what I've set up is just a basic thing with GitHub that you can say, oh, whenever anyone makes a pull request, I'd like to check certain things. And this is just checking the code compiles, it's building everything, and then run the unit tests, and then check formatting, and then if that's all okay, then allow you to merge the pull request, which is a bit of a sanity check. Okay, so everything worked and nothing failed, so I should be able to merge. I reckon everything is done. This message is still okay. Okay, so merging, merge. Right, so, and then these changes should have landed in master, I reckon. Oh yeah, that number looks like it's gone up. Yes, okay. So the code has now changed. So I think that is everything. Oh, you're just seeing a white screen. Let's have something nice to look at. So I reckon that's about wraps things up. So thanks everyone who's come along. I'll be streaming again next week, same time. So yes, I think that's everything. We got some good stuff done as well. We got a pull request merged, and we've got more functionality now. We did that stuff is now working that wasn't before. So I think that's a success. So I will hopefully see you all next